Now it's time to talk about calculations, how to do calculations with vector of values. But before we actually start talking about calculations, let me explain two very important things. It's a coercion and conversion. What it means. Well, first of all, you remember that in R as well as many other programming languages, in vectors, all values in the vectors, all items in the vector should have the same type. So you cannot combine, strictly speaking, numbers and text or numbers and logical values in one vector. But what happens if you try to do that? Okay, then R will try to coerce. R will try to find a type which actually fits all the values. So let me explain that, and that's what is called coercion. First of all, I create a vector similar to what I used in the previous examples. It's a named vector with 3 numeric values, right? And then you probably noticed it already that all code I showed you in these yellow boxes, you can just run this code in the R console and then see the output and then compare the output with what I have. So please, every example you see in this video, please try these examples also. Okay. So now look, the idea is following. Character, it's a type of data that actually has the highest rank. You will see why. Because anything can be a character. You can make a number a character, you can make a logical a character. So it means that anything can be coerced and anything can be converted to character. The next in this hierarchy is number. You cannot convert any character to number, right? But you can convert any logical value to number, okay? So therefore, when you do this, when you have this problem, when you try to combine several things together in one vector, R will try to coerce. First of all, it can coerce from logical to numeric values, and then it can coerce from numeric to text. So that's how it looks like. Now, what I did in this particular example, you can see I have a vector with numeric values, right? So by that time, when I created the vector, all values were numeric, all 3 values were numeric. And then I ran this command. What I said assign a value of 175 to as a second value, as a second item of this vector. But look, I use quotes here. So in fact, it's not a number 175, it's a text value 175. Usually you can expect that the interpreter should give you an error, but in R, it behaves in a different way. When you try to combine several things, several different types together, it simply coerces the values. So it looked and then see, okay, 175 is a text, 180 is a number, 190 is a number. So it converts everything to a text. So now if you look at what values you have in A, you will see that you have text values. So it's not numbers anymore. For example, you cannot do arithmetical operations anymore with these values because they are text values. Okay. The same happens if you try to combine, for example, logical and numeric values. In this case, you can see that I created a vector B and I use function C to combine values, and I combine 2 different types of values. I combine 2 logical values, true and false. Then I combine a numeric value. Again, I try to do something that cannot be done, but R takes it by doing coercion. So it tries to find a type that actually fits all 3 values, and that happens to be numeric. Because true, you can think of true as 1, and then you can think of false. False is 0, right? So 0 in 1 instead of true and false, and that's what R does, right? So you can see that instead of false, we got 0, instead of true, we got 1, instead of 100, I mean, not instead, but 100 is 100, right? So every time you mix the values, R does this coercion. Why it's important to know? Imagine that you have an Excel table, and for example, you have a column in this Excel table, and then you have some numbers in this column, right? And then imagine that at the end you have a text, for example, I know, sum. Yeah? If you try to read this vector into a vector, if you try to read this column into a vector in R, and we will learn how to read data from Excel files later, you will not get numeric values. All these values will be text values because one of the values is not numeric. That's very important to remember that, and it's very important every time to read any data values from any files, or when you create data values, you need to check if you have the correct type. Because if you read this data and then it happens to be text data, not numeric data, because of coercion, and then when you try to do any arithmetic or mathematical operations, of course you will get a lot of errors. So always check your data type before you actually do the calculations. In fact, you can do this coercion manually, so you can actually convert one type of values to another type of values if it's possible, and R has some functions for that. So actually there are many functions. I decided to show you only 5, and actually we will use only 3 out of these 5. You can see the 3 functions as numeric, as logical, as character. So these functions, they take a value or a vector of values, and then they try to make this vector as numbers, as logical values, and as characters, as text values. Let me again show you a couple of examples. So in this case, you can see I create a vector A, and this vector will contain text values. So we have text values here. But look, all these text values can be converted to numbers, right? So if I run the following command, b equal to, and then take a and convert to numbers. So this is what this function does. It takes all values from a and convert to numbers, and then save these values to b. Now you can see b is a numeric vector. So if you have numbers as text values, you can convert them to real numbers. And now you can do arithmetics and mathematics with these values. Okay. Then similarly here, now I take b, so I take these values, I just produce them, right? And I say as character, so it means that take all these values and convert them to text. Now, and then save it to C. Now you can see C is, and it's the same as A, right? What happens if you can't convert a value? So for example, again, in this case, look, I have a vector with text values, and 2 of them can be converted to a number, but R cannot convert this one because, R does not understand English language, right? So what happens if I use as numeric in this case? Well, R will try to do its best. So it means that it will try to convert as many values as possible. And if there is a value that cannot be converted, it will use NA. You remember NA is a missing value, right? Not available. So R will replace this value with this NA, okay? And you will also get a warning message. So warning, it means that it's not an error. So it means that R was able to complete this operation, but the result is not the same as expected. So there were some problems on this when it tries to run this function, and that's the problem NA, right? So you will see this message here, okay? And then similarly, you can convert, for example, logical values to numbers or vice versa, okay? So remember about coercion and conversion. It's very important. And always check type of your values before you do the calculations. Now let's talk about how to do the calculations. Well, let's start with the simplest case. It's arithmetic operations, and let's talk about arithmetic operations between a vector and a number. So if you have a vector like I have here, so it's a vector A with 3 different numbers, and then you can do 4 arithmetic operations where you have a vector and a number. For example, plus, or for example, minus, or multiplication or division. In this case, the situation is very simple. R will take every value from vector A and then does this arithmetic operation with this value. So for example, you can see in this case, it took 10 plus 5, then 20 plus 5, and then 30 plus 5. Okay. And then the similar you have for subtraction, the multiplication, and the division. So that's pretty simple. If you have a vector and a scalar, every value from the vector has an arithmetic operation with this scalar. So either you add value, subtract value, multiply value, divide value. So that's pretty simple. Now what happens if you have 2 vectors? Then the idea is very similar, but now it will take element by element. So for example, if you have a plus, so it will take 10 plus 2, 20 plus 4, 30 plus 5. So it takes every element from one vector, then corresponding element with the same position, with the same index in the second vector, and then apply this arithmetical operation here. So that's an example. You can see that A plus B will produce 12, 24, and 35. It's exactly what I did here in this example, right? And then if you do the subtraction, so 10 minus 2 will be 8. 20 minus 4 will be 16, and then 30 minus 5 is 25. Then you can see similar results for the multiplication and division. So if you have 2 vectors of the same length, the operation is always element-wise, so element by element. Now, what if vectors have different size? Well, again, R tries to do the best. And from our point of view, the best is the following. Look, in A, I have 4 values, right? So I have 4 values here, and I have 3 values here. So strictly speaking, the operation is not possible. But what R will do, it takes the smallest vector, in this case it's B, and simply cycle it. So it will sort of make a longer vector and add 2 here. So it will take this value and put it here, okay? And then the rest will be the same. So now you have sort of 4 values in each, and then the result will be what you can expect. But of course, it's something extraordinary, and R will show you a message about that. So you'll get again a warning that something went not exactly as you expect. Okay, so that's the example. I take this, I should use this one, right? It doesn't matter, as I said, but just to be consistent. So I took A plus B, and since A and B have different length, first of all, I got a warning message. It says that longer object length is not a multiple of shorter object length, right? And then what you see as a result is 12, it's 10 plus 2, 24, it's 20 plus 4, 35, it's 30 plus 5, and then 42. So it took 40, and then it starts the vector B again from the 2, right? So 40 plus 2. So remember about that, and be careful, because sometimes it can lead to some wrong calculations. So watch out what R tells you, especially all warnings and all error messages. Now, in addition to mathematical operations, R also has a lot of different mathematical functions. Almost everything you can imagine exists in R. Again, I took a vector with 3 numeric values, and then, for example, I use a hat. You can think that this is operator, not a function, even though in R everything is a function. So hat means a power. And again, if I apply a power to a vector, it simply does it for every element, right? So in this case, it squares every element. 1 squared, 2 squared, and 5 squared. Yeah? You can also apply different functions. You remember, we already used function as QRT. And before we used function as QRT to one value, if you apply this function to a vector, you will have as many outcome as many values you have in the original vector. So it takes 1, take a square root of 1, takes 2, take a square root of 2, and so on and so forth. So it applies a function to every element of this vector. Then the same about logarithm. For example, if I take logarithm A, so logarithm of 1 is 0, logarithm of 2 is 0.69, and then 1.61. And then by default, this logarithm is a natural logarithm. Natural logarithm, it means it has a base e, but you can also use decimal logarithm and binary logarithm if you want. Okay. So once again, R has a lot of math functions, all trigonometric functions, and everything you can imagine exists in R. Okay. Finally, statistical functions. What is statistics? Statistics is something that summarizes your values, right? So if you have a vector, the statistic of this vector is just one value. And that's the main difference between statistical functions and mathematical functions. Mathematical functions being applied to a vector returns as many values as many you have in the vector. Statistical functions almost always returns only one value. Again, let me show you an example. Again, I use the same vector A with 3 values, 1, 2, and 5. And then the first function, the simplest one, is sum. So sum simply sums up all the values. Then you can see the result will be only 1, it's 8. Then you can see it's simply 1 plus 2 plus 5, it's indeed 8. Huh? Prod takes a product, so it takes all values in vector and take a product of all values. You can see 1 times 2 times 5 will be 10, and this is exactly what I have here. Or, for example, you can think about more traditional statistical functions. So in this case, I calculate mean, average value, and then again you can see that I got only one outcome. So again, most of the statistics exist. You can calculate standard deviation, you can calculate correlation, you can calculate many statistics. The basic idea is that most of the statistical functions, they takes a vector and then kind of summarize the results of this vector by calculating one statistic per vector. And then, of course, when you do the calculation, you usually end up with numbers, with decimals, and then sometimes you need to round the values. You already used the rounding values in BMI in the example for the last learning sequence. Now I will tell a little bit more about that. So you can see again, I created a vector. I should be consistent. I created a vector A with 3 values, and you can see that I have 3 decimals in each. Now I'll show you 3 different functions that actually can do the rounding. The first function is sailing. In sailing, it simply rounds everything up so to the closest largest decimal. And you can see that we have 2 here and a little bit more than 2, so the closest largest decimal will be 3. So we have values between 2 and 3, so it's between 2 and 3, 2 and 3, 2 and 3. In sailing, it always rounds up. Okay, it's like a sail, right? So in this case, you can see the result is 3, 3, and 3. Yeah? Alternatively, you can use floor. Floor, it's the same as sailing, but the other way around. So it will round down to the closest decimal. Then you can see it's 2, 2, 2. And of course, you can always use round. That's what we already know. If you just apply it round, you can see that you got 2, 3, and 3. And that's reasonable because you can see that this is larger than 2.5. This is larger than 2.5, right? Larger than 2.5. And this is smaller than 2.5. So that's why you get it 2, 3, and 3. Alternatively, you can also produce not an integer number, but a number with a predefined number of decimals. For example, you can say, I need only 2 decimals or 4 decimals and so on. And that's what you can see in this example. I say round values from A, but keep only 1 decimal, not 0 decimals, but 1 decimal. And that's what we got, 2.3, 2.5, and 2.8. Again, if you look at the original numbers, you can see why actually we got these values. So this is how to round numbers. And then sometimes you also need to sort numbers, right? So sometimes you need to sort from the smallest value to the largest or vice versa. And then that's how to do that. Again, that's the vector I'm going to use. And function sort actually sorts the values. So you can see that if you apply sort, you get the same values, but in the increasing order. So this is the smallest value, and this is the largest value. Okay. And then if you want to do the other way around, if you want to make it decreasing, you simply provide an extra argument to function sort. You say decreasing equal to true. By default, it false. And then you can see that now the values are sorted in the other direction. So you have the largest value first and then the smallest value last. Okay. Sometimes you need to get an index of the sorted values instead of values themselves. And to get an index, you can use function order. So what function order does, what's the difference between function sort and order? Order returns indices. For example, you can see that I say order A, and this is the numbers I got. So this one, it's where you have the smallest value, and that's -1. You can see number 4, number 1, 2, 2, 3, and 4, right? So number 4, it's the smallest. Number 2, it's the next smallest. You can see indeed it's this one. Number 3, it's the next smallest, and then number 1 is largest. So it shows you simply the indices instead of the values. And if you want to get the values, you can simply reshuffle your values by using these indices. So if I write this one, you can remember that this is for subsetting, and then it says, okay, first take value number 4, so you get -1, then take value number 2, you get 2, then value number 3, you get 5, and then value number 1, you get 10. Okay, so this is how order works. So if you need to order values, if you need to get the values ordered, then you use this function. If you need to get indices, then you use this function. Okay. So that's a very short overview of what you can do with vectors in terms of calculations, arithmetic operations, and some functions, and also how to sort the values. And actually, I think that's it about atomic vectors. Now you know how to deal with atomic vectors. And in the next video, we will talk about higher order data objects in R, how to combine these atomic vectors into big tables.